tracking a jellyfish in the ocean's twilight zone. Aerobots or unmanned aerial vehicle, commonly known as drones, and hydrobots or unmanned underwater vehicles have helped us in exploring the most inaccessible corners of our world, from deep oceans to deep space. Aerobots have applications ranging from surveillance and reconnaissance, terrestrial mapping and imaging, disaster management, environmental conservation, and so on. Hydrobots are used for service and maintenance of subsea oil and gas installations and research on marine life. But such aerobots and hydrobots have been remotely operated and require a trained crew for operation. Moreover, they have limited range and often used for repetitive tasks only. Artificial intelligence can transform aerobots and hydrobots into truly autonomous robots by introducing human-like cognitive capabilities and decision-making. This will be possible with rapid advances in computing and communication, coupled with realization of accurate sensors, high-performance actuators, and robust algorithms. In space, AI-enabled aerobots can be used for the routine visual inspection and assembly tasks, as already demonstrated by robots on board the International Space Station, as well as more complex and challenging tasks such as extravehicular activity, capture of non-cooperative space debris, orbital reorientation, in-orbit repair and upgradation of satellites. Space rovers and aerobots such as balloons, aerostats, and rotorcrafts tend to be expensive and have limited range. Due to the inherent communication delay, they need to be smart enough to perform autonomous operations. AI can improve the performance of the robots and enable autonomous mode of operation, especially in navigation, object localization, and mapping. Autonomous hydrobots with AI can also be used for exploration of subsurface oceans in icy planetary bodies. As ISRO is embarking upon challenging missions like sending humans to space and exploration of near and far planetary neighbors, a plethora of technologies need to be developed to incorporate AI-enabled autonomous operations into mainframe systems and functions. Aeronautical Society of India has been promoting the advancement and dissemination of knowledge of aeronautical and aerospace sciences and technologies since 1948 and has been providing a common platform to the aeronautical community to exchange the scientific ideas. ISRO Inertial Systems Unit IISU has 30 years of experience in the development of highly precise optoelectromechanical sensors, actuators, and mechanisms. This expertise, integrated with innovative AI techniques, has led to the development of robotic systems for space applications. IISU is currently developing Vyom-Mitra, the half-humanoid space robo for Gaganyaan unmanned mission, and an aerobot named Smart Space Robo. Indian Institute of Space Science and Technology (IIST) is the first university in Asia to be solely dedicated to the study and research of outer space. Recognizing the importance of research in developing future technologies and applications of space research, the Institute prepares high-quality, industry-ready candidates for aerospace arena. In order to prepare the professionals, students, and entrepreneurs to the demands of the future, AESI Thiruvananthapuram branch, in association with IISU and IIST, is organizing this two-day national conference on artificial intelligence-enabled Aerobots and Hydrobots. Robotics and AI amplify human potential, increase productivity, and are moving from simple reasoning towards human-like cognitive abilities. With rational and harmonic interaction between application-specific projects, visionary research ideas, and sustained responsible investment from both industry and government, AI is set to transform the future of our society. A robotic helicopter flying autonomously in Mars, a marine robo tracking a jellyfish in the ocean's twilight zone. Aerobots or unmanned aerial vehicle, commonly known as drones, and hydrobots or unmanned underwater vehicles, have helped us in exploring the most inaccessible corners of our world, from deep oceans to deep space. Aerobots have applications ranging from surveillance and reconnaissance, terrestrial mapping and imaging, disaster management, environmental conservation, and so on. Hydrobots are used for service and maintenance of subsea oil and gas installations and research on marine life. But such aerobots and hydrobots have been remotely operated and require a trained crew for operation. Moreover, they have limited range and often used for repetitive tasks only. Artificial intelligence can transform aerobots and hydrobots into truly autonomous robots by introducing human-like cognitive capabilities and decision-making. This will be possible with rapid advances in computing and communication, coupled with realization of accurate sensors, high-performance actuators, and robust algorithms. In space, AI-enabled aerobots can be used for the routine visual inspection and assembly tasks, as already demonstrated by robots on board the International Space Station, as well as more complex and challenging tasks such as extravehicular activity, capture of non-cooperative space debris, orbital reorientation, in-orbit repair and upgradation of satellites. Space rovers and aerobots such as balloons, aerostats, and rotorcrafts tend to be expensive and have limited range. Due to the inherent communication delay, they need to be smart enough to perform autonomous operations. AI can improve the performance of the robots and enable autonomous mode of operation, especially in navigation, object localization, and mapping. Autonomous hydrobots with AI can also be used for exploration of subsurface oceans in icy planetary bodies. As
Ladies and gentlemen, a very good morning to all of you. The aerospace industry is highly diverse and span across military, commercial, aviation, and space sectors. Emerging technologies like artificial intelligence in the aerospace industry can help companies streamline manufacturing while also addressing their safety concerns. Artificial intelligence can simplify analytics, system management, customer service, and various other processes and activities. The aerospace industry is a mission-critical industry, and its success depends on components that need to be highly reliable and accurate. Space environment and microgravity pose unique challenges to emerging opportunities for human-robot and robot-robot cooperation in space, atmospheric, and underwater exploration. Therefore, the combination of aeronautical engineering, space technology, and robotics enabled with artificial intelligence is a game changer in aerospace for earthbound, on-orbit, and interplanetary applications.
The future demands that professionals, students, and entrepreneurs need to adopt technologies for the benefit of the nation. The National Conference on Artificial Intelligence-Enabled Aerobots and Hydrobots, organized by the Aeronautical Society of India, Thiruvananthapuram branch, in association with Vikram Sarabhai Space Center, ISRO Inertial Systems Unit, and Indian Institute of Space Science and Technology, will be formally inaugurated here today. The 2 days national conference is aimed at understanding the importance, challenges, and inter-domain synergy of artificial intelligence, space robotics, aero and underwater robotics, and smart drones. Intelligent UAV, drones, VTOL robot, autonomous drone for low Earth orbit and unmanned space probe, microgravity space robotics, planetary space robotics, and many more such cult topics will be deliberated in this conference. I, Neha, and my co-host Vimal deem it a pleasure to extend a very cordial welcome to each and everyone present here.
Before we move on, may I request Dr. D. Sam Dayaladev, Chairman, Aeronautical Society of India, Thiruvananthapuram branch, and Dr. Mohan Kumar L., Honorary Secretary, Aeronautical Society of India, Thiruvananthapuram branch, to usher the dignitaries onto the dais. Sri S. Somnath, Chairman, ISRO and Secretary, DOS, Sri A.S. Kiran Kumar, National President, AESI, and former Chairman, ISRO, Dr. S. Unnikrishnan Nair, Director, VSSC, Dr. V. Narayanan, Director, LPSC, Sri A. Rajarajan, Director, SDSC.
Thank you, sirs. We begin today's program by invoking the blessings of God Almighty. May I call on stage Srimati Sridevi Bhatt to render the invocation.
दूसरों की जैसे पहले खुद को जय करे, भेद भाव अपने दिल से साफ कर सके, दोस्तों से भूल हो तो साफ कर सके, झूठ से बचे रहे, सच कदम भरे, दूसरों की जैसे पहले खुद को जय करे, हमको मन की शक्ति देना.
Thank you, Shri Devi. Dr. D. Sam Dayaladev, Chairman, Aeronautical Society of India, Thiruvananthapuram Branch, and Director, ISRO Inertial Systems Unit and Indian Institute of Space Science and Technology, has been the chief designer of ISRO's next-generation Advanced Inertial Navigation System based on ISRO Laser Gyro and innovative low-cost navigation systems for SSLV. Currently, he is leading teams in developing autonomous navigation systems with ultra-stable inertial sensors for long-duration missions of ISRO and vision-based navigation system. Synergizing the multi-domain expertise and knowledge base of IESU teams, he has initiated AI and ML-enhanced space robotics activity. The Smart Space Robot, SSR, a technology demonstrator for space debris management and half-humanoid for first unmanned Gaganyaan mission as an astronaut assistant are being developed under his active involvement and leadership. He has many awards, various publications in national and international journals, and book chapters on advanced manufacturing methods and precision engineering to his credit. He is a fellow of Aeronautical Society of India and holds many patents as the first inventor. May I request you, sir, to formally welcome the gathering and brief us on the theme of the conference.
Yeah, very good morning to all and wish you a very safe participation in the conference. We will be following strict COVID protocols during the course of the conference. Respected dignitaries, Shri S. Somnath, Chairman ISRO, Secretary DOS, Shri A.S. Kiran Kumar, former Chairman ISRO and National President of Aeronautical Society of India, Dr. S. Unikrishnan Nair, Director VSSC, Dr. V. Narayanan, Director LPSC, Shri A. Rajarajan, Director SDSC, Dr. Mohan Kumar, Honorable Secretary, AESI Trivandrum Chapter, and other dignitaries of the dais. Ladies and gentlemen, a very good morning to you all again. It gives me immense pleasure to welcome you all to the two-day annual National Conference of Emerging Trends in Aerospace Technology with the theme Artificial Intelligence-Enabled Aerobots and Hydrobots, organized by the Aeronautical Society of India, Thiruvananthapuram branch. I feel honored and privileged to be part of the organizing team of the conference as Chairman AESI Thiruvananthapuram branch and Chairman Local Organizing Committee. ASET 2022 is jointly organized with the ISRO Inertial System Unit and Indian Institute of Space and Science Technology, IIST, and is being conducted at Vikram Sarabhai Space Center, Thiruvananthapuram. Artificial intelligence is impacting all realms of human life and the future of every industry. All the emerging technologies of today's world, such as big data, robotics, IoT, all revolve around AI or artificial intelligence, and it will continue to act as a technological innovator for the foreseeable future. Aerospace and robotic sectors are no exception, and a major revolution catapulted by AI awaits this sector too. The topic of the conference has been thoughtfully chosen as AI-enabled aerobots and hydrobots. In comparison to the terrestrial robotics area, where AI has made a foray in major way, aerospace and marine applications offer more challenges and opportunities and is waiting to be explored for the union with AI. The integration of aeronautical engineering and AI will make path-breaking advances in aerospace sector. From implementing autonomous navigation and prediction systems for UAVs, drones, and air taxis, and decision support systems for launch vehicles and spacecrafts. The application of AI has been increasing in recent years, is overlapping with the thriving area of space robotics too. On-orbit operations such as satellite servicing, repairing or refueling, and space debris management are potential areas where the amalgamation with AI can bring in exciting and interesting results. There are exciting challenges in the planetary space robotics area also due to the harsh and unknown interplanetary terrain and environment. Proximity operations and fast-changing dynamics coupled with communication delays in both these areas call for independent and autonomous decisions where AI has a major role to play. Space robotics and AI also has emerging applications in planetary human exploration missions, in developing intelligent mission operations, intelligent robotic agents as working partners for the crew, culminating in enhanced human-robo collaborations. Despite all the trials and tribulations of the pandemic striking the world, AESI continues its activity in promoting the advancement and the dissemination of aeronautical sciences and engineering. Considering the logistics and operational issues, ASET 2022 is organized in a hybrid mode to ensure maximum participation of aerospace community. To leverage the expertise of academia and industries who have effectively woven AI into the robotic fabric, we have selected distinguished persons playing key roles in this area for the invited lectures. For this year onwards, Aeronautical Society of India is organizing a special technical address for ASET as Sri S. Ramakrishnan Memorial Lecture, as remembrance to late Sri S. Ramakrishnan, former Director VSSC and LPSC, who has made immense contributions to the aerospace and propulsion sector in India. We are indeed honored to have the first Sri S. Ramakrishnan Memorial Lecture delivered here today by Sri R.V. Perumal, former Director of LPSC. Now I move on to welcoming as representing the organizing committee ASET 2022, and we offer sincere gratitude for the advice, encouragement bestowed by Sri S. Somnath, Chairman ISRO, Secretary DOS. He is also one of the patrons and the Chairman of National Advisory Committee. It is a great honor and privilege for AESI that Sri S. Somnath, Chairman Secretary DROS, is here with us today to inaugurate the conference and deliver the inaugural address. Sir, we are privileged and happy to welcome you to this conference and inaugural session. The organizing committee is also extremely proud and honored by the presence of Sri S. Kiran Kumar, Bikram Sarabhai's professor and former Chairman ISRO, and our proud National President of AESI, and thankful to him for giving his consent to release the souvenir and address the gathering. So we welcome you, sir, for this inaugural function. I also acknowledge with gratitude and immense support accorded by Director VSSC, Dr. Unikrishnan, who has been very supportive in making all the facilities available for the conduct of this conference. And we welcome you warmly, sir, and to preside over this function. I do acknowledge the immense support given by Director LPSC in organizing the conference and agreeing to release the proceedings of the conference. So, sir, I welcome you to this inaugural session, sir. I am very happy to thank and welcome Sri A. Rajarajan, Director SDSC, who has traveled to attend this conference on our invitation. We welcome you, sir. I take great pleasure in welcoming Sri R.V. Perumal, Director LPSC, who has consented to deliver the first Ramakrishnan Memorial Lecture and readily agreed to be available in person. I welcome you, sir. I welcome Dr. Mohan Kumar, our Honorary Secretary, who was behind all these arrangements and toiled for. I welcome you, sir. The harder you strike the flint, the brighter the spark. I salute every member of the ASET 2022 Local Organizing Committee and various functional committee members for your dedication and untiring efforts in conducting the conference. I also express my sincere gratitude to various industry partners who are participating in the conference as sponsors, exhibitors, and advertisers in souvenir. I welcome you all with great pleasure. I wish the distinguished invited speakers, invited dignitaries, delegates, and other participants all the very best during the conference. I hope the conference will provide opportunities for purposeful and scholarly deliberations in the area of AI and robotics to provide definitely a unique future directions and fuel the thought process, culminating in innovative solutions for the betterment of the mankind. I welcome you all again and thank you. Jai Hind.
Thank you, sir, for your warm words of welcome. On behalf of the organizing committee, we extend a warm welcome to you as well. Dr. S. Unnikrishnan Nair, Director, Vikram Sarabhai Space Center, is an expert in the areas of launch vehicle mechanisms and acoustics. As the founder director of Human Space Flight Center, he was instrumental in setting up environmental control, life support systems, and astronauts training facilities. As a member of the study team and later the project team for Space Capsule Recovery Experiment, SRE, he was associated with Indian Human Space Flight Program since its inception. During his tenure as the project director of HSP, critical technology development activities like Crew Module Atmospheric Reentry Mission CARE and demonstration of crew escape system through pad abort test were successfully accomplished. It is my pleasure to invite you, sir, to deliver the presidential address.
Good morning to all. So pleasing and pleasuring to see so many people in direct mode because we are used to online type of workshop or seminars last 2 years. Of course, online has got its own advantages like you can say participation is better, you get speakers from across the globe, but this feeling of interaction we will never get. So we have our beloved chairman, Sri S. Somnath, Sri Kiran Kumar, National President ASI, Dr. Shyam Dayal Dev, Director IST and the main force behind the ASI in Thiruvananthapuram, and Dr. Narayanan, Director LPSC, Sri Rajarajan, Sri Mohan Kumar, Sri R.V. Perumal, who is going to give the Ramakrishnan Memorial Lecture. A very good morning to all of you. Anyway, we all know that artificial intelligence is, we are all benefited by that, maybe from a simple way to a profound way in many ways. When we click the email or when we just get instructions on traffic or when we select music or when we use social media or knowingly or unknowingly, artificial intelligence is playing a role. It's affecting us in many ways. You have seen in that movie Interstellar how a robotic assistant is helping the humans to detect lives on, say, other planets. So that is a profound application of artificial intelligence. It's also true that there are many AI-enabled robots like Astrobi or Simon. They are getting experimented in space station and they are conversing with the astronauts and they are developing. So right from the beginning, when we started the Gaganyaan program, of course, this is not a astronaut, maybe robots are not essential for a short-term mission. You go to space and come back. But when we set out on a mission or a long-distance mission to say to Mars or something like that, so it's important that we have a companion. It's not a machine with artificial intelligence, but it has got empathy as well as sympathy, which can take the feelings of the astronaut and then console him. So it's a different dimension that the AI is evolving into and then giving us hope for such long distance mission. I, as Director of VSSC, I take this opportunity to welcome all of you to this 2 days conference, which AESI Thiruvananthapuram chapter, usually they select important topics, very relevant topics, and this time also right from robots from underwater to deep space, the topic covers the entire area. And we see through direct as well as online, so many people with natural intelligence. So we will hope this interaction between you and the artificial AI-enabled robot will definitely give us a roadmap how we are going to work in future. It is true that we do in such AI areas also in pockets there are activities, in VSSC there are activities, in SAC, in URSC, like that, IASU. As it was mentioned here, they have made a half humanoid which we are going to test in the G1 mission. That is a beginning. Probably as we progress, when we undertake long duration mission, along with artificially AI-enabled robots also will become more powerful, and then they become co-travelers in our future missions. So I wish the function or the 2-day conference a very success and a fruitful deliberations and some very strong roadmap at the end of this 2-day conference. Thank you.
Thank you, sir. We now move on to the formal inauguration of the conference. We feel deeply honored to have with us today Shri S. Somnath, Chairman, Indian Space Research Organization and Secretary, Department of Space. He is an exemplary space scientist and an expert in all frontiers of space technology. Shri S. Somnath has efficiently spearheaded the GSLV Mark III X mission, which demonstrated the successful recovery of the crew module, paving the path towards India's human spaceflight. As Director VSSC, he mentored the team to develop the Small Satellite Launch Vehicle SSLV with innovations for cost reduction and ease of production. He played a key role in the review of engineering systems and human factors of Gaganyaan, thus shaping ISRO's DREAM project. He is the Vice President of International Astronautical Federation in charge of the technical activities and is a member of International Academy of Astronautics. It is my pleasure and privilege to now request Shri S. Somnath, Chairman ISRO, to inaugurate this conference by lighting the traditional lamp and to deliver the inaugural address thereafter. May I also request all the dignitaries on the dais to join him in lighting the lamp.
Good morning, all of you. Respected Sri A.S. Kiran Kumar sir, the National President of Aeronautical Society of India and former Chairman ISRO, Dr. Unnikrishnan Nair, Director VSSC, who is presiding over this function, Dr. D. Samdayala Dev, Director IASU and IAST, and also the Chairman of the Aeronautical Society of India, Thiruvananthapuram branch, Dr. V. Narayanan, Director LPSC, Sri Rajarajan, Director SDSC, Dr. Mohan Kumar, Honorary Secretary of Aeronautical Society of India, Sri R.V. Perimal, former Director of LPSC, who is delivering the memorial lecture in the name of Sri S. Ramakrishnan, Sri Adimurthy sir, and also people from IAST, the Registrar, Dr. Ayyappan, Registrar Krishnamurthy and Ayyappan, then Kunjagabanan sir, I am seeing, and most seniors from ISRO centers, and all the delegates who have come for this conference, being organized partially in offline, and then of course there are some virtual online lectures here. So also like to greet Professor V. Kamakodi, who is going to give very interesting lecture, and Dr. Pramod Kumar Maurya, and also Sri Sangeet Kumar, who is going to speak in the afternoon sessions on very important topics related to the theme here. So my greetings to each one of you for being here and then part of this conference on artificial intelligence enabled aerobots and hydrobots. So when this theme of this conference was being thought about, Sam Dayal there was suggesting, at that time I was the director of VSSC, and he was so keen to ensure that a specific theme in this direction is appropriate for such a conference in Aeronautical Society of India. Of course, we have been dealing with most aeronautics and astronautics related topics. And of course, there is a strong link between what the primary topic today as well as the space technology, which of course we will hear in the later talks. As we really know, the artificial intelligence is something that I always been intrigued by the terminology of that we are speak about artificial intelligence. Of course, we thought that we are all intelligent beings, and the moment we start speaking about artificial intelligence, I ask this question myself many a times, whether the intelligence is actually data-driven. Our intelligence came out of the accumulation of knowledge, rather the data that we have been collecting through our sensory perceptions and then stored as memories in our mind or the brain, and process it to create certain reasoning, assumptions, conclusions for new issues that crop up in front of us. This we call intelligence, really. The intelligence do mean that we have an ability to reason and on observations that we have in front of us, discover meaning on whatever we see, perceive, and of course find out processes which will generalize what you see now to some previous experience, so we can draw some conclusions. And also, we know that intelligence is something that we allow us to learn from experience. I think these are the things that we understand by the term intelligence. And now we talk about artificial intelligence. And still the question to me is whether this artificial intelligence is data-driven. The moment that we are creating intelligence through processing of the data that we have accumulated, or the machines accumulated, or we feed to the computers and then derive certain intelligence out of it, it happens to me that there has been a lot of literature with respect to people who have seen the other side of the human existence, and they say intelligence is not necessarily data-driven. And it can also be created when there is absolutely no data in the mind, and we keep our mind very free of all thought processes. Whether we don't bang on the experience, we get into a different realm of intelligence. Of course, this is something that we need to be debated, understood by people who have an ability to do that. But today, that I believe that we are discussing only those intelligence which is associated only with the data and processing of the data, and we derive certain conclusions out of it by appropriate processes. I believe that intelligence is something that will enable us to adapt to new situations and new circumstances or changed circumstances. I think this is what is very, very important. If you see the same thing again and again, of course, we see there is no great intelligence. For small bees or creatures, they have something called intuitive behavior. We don't call it intelligence because there are a lot of small creatures where after birth, they know how to collect food, how to live, how to build their whole home, how to save themselves from extinction. All these are inherently into them without any training or without any knowledge extra to be collected. So this is a natural instinct. I don't know whether this is still an intelligence. It is something much beyond that. Also, another link on intelligence is something I think that our ability to think in using languages. I think, no, I don't know, human beings have an ability to reason, think using the languages that each one of us have. Languages could be in different forms. The one which we speak, think, or imagine. It can be colors, it can be forms, it can be shapes, it can be the oral languages. Finally, we process the data using the method called languages. And without languages, can anything be intelligent? I don't know. Can you ever think without language being there as a material behind processing all this data, like a software processing the data? These are questions which I don't have answers. Probably, no, some of the experts who are sitting here, maybe Sam himself can give answers to this, but I was thinking about all of this when we wanted to give this talk today. See, one of the important point which the challenge for people who are working in artificial intelligence, machine learning, is to produce machines with an overall intelligence ability no different from humans. I think this is something that we call the ultimate level of an AI-enabled systems can reach, replicate humans. But then is it the highest level or anything beyond that is possible? I think beyond that also possible. It will come when really integrate human beings to machines. I think the human beings connected to machines will be the best ultimate power. I think this will amplify an ability of a human being to really do certain things. For example, ability to process data. Ability to recover data on command. I think we have our human brain neurons actually lose memory over time. It doesn't have an ability to preserve memory for longer durations of time. The ability to store memory is actually limited. To collect fresh knowledge and keep it there is actually limited. We cannot plug in a new hard disk and then get new knowledge within no time. It takes time and effort to gather knowledge or data. So when you interconnect a supercomputer to human beings, I think the ability of the human beings will extend beyond what we know today. I think this is something which I look for the new generation really to happen. But coming back to the domain which we are discussing today, the artificial intelligence-enabled robots and aerobots. Again, coming back to the robots, specifically those robots which you see every day, I think plenty of them are there in midst of you. I purchased one, the MI robot for cleaning my room. It's a robot which will detect the obstructions and do the mopping of the room, clean, and I can program any room today, and then it will go to the next room. And next day I put it here, it knows where it is, and then it will do itself all those cleaning actions. Only when the dust collector becomes full, only I need to go and replace it. So very beautiful robot are at home now, doing many activities. But some of the technologies which leads to the growth of robotics in the recent years, especially in those domains which we are deal with in space, I believe they are connected to the drives and actuators, where the electric motors becomes one of the important element. The work on electric motors, drives, and have been happening in ISRO. And here there are many things which are connected, the materials which goes into it, the magnetic material, specifically the ability to design motors for various purposes, super efficient in terms of its ability to convert electrical power to mechanical power, efficiency. Correspondingly, the power drives that goes with these motors. The mechanism part of it, because robots, large number of mechanisms are integral part of any robot system, because we need to do actuations and actuators, precision to point it, ability to measure positions, accelerations and velocities, to do the required closed loop control. When you talk about aerobots, of course, the aerodynamics comes in place, the propellers, the ability to convert mechanical drive to the aerodynamic forces, the efficiency to create those controls through the control of aerodynamic surfaces in this. All this becomes very important. And another domain which is equally important is in terms of processing capability, the computers, because the power is premium in any robotic system, because it doesn't draw power from outside, it has to be from inside. The batteries, energy systems, the lesser the power it comes used for computational needs, the stringing of the processor and energy efficient processing actually makes robots much more possible today. Also the algorithms which comes in, the algorithms are all coming out of various fusion of sensors. Now, earlier used to be only few sensors. Now, sensors are becoming so many in a given situation. You know, typically in an automobile which is now automatically driven, the number of processors and sensors are too many. So it has to work with a very distributed architecture to make a self-driven car possible. And even your normal cars are also having multiple processors where you drive still. So sensor fusion becomes very important, and the ability of software to handle complex sensor logics and failure modes handling, all this becomes very, very important in the new domain of artificial intelligence. Of course, we all realize that the algorithms of control, guidance, and navigation is one of the very important element of robotics, because it has to realize its own location space for further activities. In space technology, of course, we know the robotics plays very, very important role. It has been ever since we started the moon landing onwards, and the type of activities happened later, docking of space stations, the scientific experiment happened in ISS, and various other robots that part of the very interesting space program throughout the journey of human beings to various planets. They are all known to you, so I don't have to elaborate. And they will continue to remain as very important element in the work of every aerospace sector. So let us discuss all of this for our work in the future. I believe the remote operations of robotic systems are going to be very, very important for us in the future, because the ability of human beings to travel vast distances and do experiments, or to go to domains where that human beings cannot easily go, such as a nuclear domain or a very dangerous activity, where a pair human being in the form of a robot can do wonders. So I believe this area requires much more sensor, human being, robot interaction, or merging them. So your thought process, how it can be understood by a robot, how his feelings can be transmitted back to us. So we also perceive the feeling of the robot in the real situation, like a feeling of high temperature, as a feeling of high temperature within our body rather than a display of temperature in front of us. The feeling of the force by the robot on our hand through the real actuation mechanism. So when such things happen, I think the robotics will go to a next level of the human-robot interaction. Even in the hydrobots area also, we have started working the deep ocean mission, in which VSSC also playing a very important role to develop not the robotic part of it, but at least the structural part of it. I believe that this is also going to be very game changer in the long term when we work on robotics. So I don't want to prolong on speaking on robotics and its related technologies. Today there are very eminent people who is speaking about it. There are papers being presented by many of you. Organizations from space organizations here, IAST, and various other speakers who are part of it. Let the 2-day sessions really be fruitful, and we start specific tasks in the organization to take this activity to a much higher level, starting from the computational improvement, the mechanisms which are very necessary for us, the drives, the power efficient drives and controllers, the better algorithms, the better sensors that will ultimately fuse into the computer systems. All these are essential to make beautiful robotic systems in the future. There are a lot of work happening across ISRO centers. Wherever I discuss, I see very surge in interest in artificial intelligence. Even in VSSC, when we created a team led by one of the deputy director to look at AI-related topics across various disciplines, from chemical to mechanical to computers and propulsion. Every area I see there is a use of AI in a big way, and I am sure it must be there in all other ISRO centers and units to work on AI. Everybody speak about AI. Yesterday I was at one of the very prominent data processing centers of ISRO, dealing with AI-enabled spacecraft data analytics, which will give very strategic information derived from spacecrafts to very fast delivery to our users. So it is there everywhere. I think the ability of many of you to understand this and make it part of your work really going to help you. But definitely do not forget that we also have some other intelligence of different nature, and don't be a pawn to the word of artificial intelligence always. I think we need to link what we know of physical so Unikrishnan mentioned about the natural intelligence which you have to the artificial intelligence in a manner that will enable us to enhance our ability much better. I think that's the purpose of all this work. Wish you all the very best, and let me inaugurate this conference today formally. and wish all the very best for the users and the participants to derive some good benefit out of this conference, leading to as part of activities in all the domains that you work. Thank you so much.
Thank you, sir, for enlightening us on the areas where AI can be put to use in the near future. Sri A.S. Kiran Kumar, former chairman, Indian Space Research Organization and National President, Aeronautical Society of India, is a highly accomplished space scientist and engineer with a distinguished career spanning over 4 decades in ISRO in the satellite payload and applications domains. He has made immense contributions to the design and development of electro-optical imaging sensors for airborne, low Earth orbit and geostationary orbit satellites, starting from Bhaskara to the Mars Orbiter mission payloads. Currently, he is the Vikram Sarabhai Professor in ISRO, Chairman, Apex Science Board, and Chairman, Governing Council, Physical Research Laboratory, Ahmedabad. He is a fellow of many professional institutes and is a recipient of many national and international laurels, including the Padma Shri Award conferred by the President of India in the year 2014. May I request you, sir, to release the souvenir and address the gathering.
Good morning to all of you. Sri Somnath, Secretary, Department of Space, Unnikrishnan Nair, Sam Dayal, Narayanan, Mohan Kumar, Rajarajan, Perumal, Adimurtiji, and all of you who have gathered here on this occasion of ASET, which is being organized by the Trivandrum branch. Now, the Aeronautical Society of India has a very active branch in Trivandrum, and Aeronautical Society of India today, if you look at, is going through a sea change, not only because what's happening globally, but also because what's happening within the country, both in terms of the opportunity and the manner in which things have shaped up in the geopolitical scenario. While India started its aeronautical activity way back and it had made significant progress prior to independence, post-independence, for various reasons, the developments within the country, particularly in non-space activities, went into in some ways a spin. But gradually things have changed, and what's happening both because of COVID and also the interactions with our neighboring countries and what you are seeing elsewhere, the need for generating and bringing in greater and greater capability within the country, whether you call it Atmanirbharata or self-reliance, is becoming more and more important. What India has shown also is that there is never dearth of talent in the country. If at all there is any limitation or lacuna, it is the manner in which the powers that be, or those who are running the country, are giving priorities for the activities. And in this context, we have also seen how the space program, which started just about 6 years after the independence, or about maybe 10 years after independence, when the first object went into space, the country had at least the wisdom of people to look at this technology. And today, while India is among the few countries with a tremendous potential, lot more of this or much more could have happened even in the aeronautics area also, if the situation, the manner in which the powers that be had looked at it differently. But anyway, things are changing. Today we are seeing that there is a significant importance and emphasis being given. Now is the opportunity for making things happen in the aeronautics area, aeronautics and space both. And some ways, when you get an opportunity to make an impact later in time, you have the benefit of knowledge of what has already been done, and that to a great extent helps. We have seen that even in our own activities also, because you are certain, you have seen already some things have been done, so you have that confidence that it can be done. Coming to the present symposium and the activities that are being planned, artificial intelligence and machine learning and use of them in the activities that are required to be done for the near future, and also to showcase that India can make a huge impact globally. We need to make sure that all the key components of these technologies are realized or made within the country. And if that has to be done, and if it has to be done effectively, it's only when we look at making this happen in a manner which is different from what has been happening so far. Because if you try to follow what has been done already, you are only going to make incremental changes in that. You are not going to bring in disruptive or a different way of looking at this thing. And it is in this context, I think, the organization of this symposium, where emphasis is being given on both robots, hydrobots, and aeronautics-related systems. How to make it happen, how to bring in new ways of doing things, and make the best use of what is already available to you and accessible to you. And if you look at what ISRO has done, it has all the time looked at whatever technology that is accessible to it, made use of it, and what is not available, developed indigenously, and make a mark, make a difference in not only the use of that technology, but the way it is applied. And in the same way, if you look at today, you are seeing that drones are miniature flying objects. If they are there, I remember reading in one of the books, a small insect flies into the room, goes around, and then when it falls short of the energy, it goes close to one of the lamps, re-energizes itself, and then it flies out. And this is actually a spy which is doing both the recording of audio-visual things, moving in and moving out of things. And today, if you look at, drones are being used in a very significant manner for various activities, both delivering as well as picking up information. And in the same manner, if you look at what is possible, the nature has shown so many examples, and what as human beings, while so much discussion is going on about artificial intelligence, natural intelligence, and intelligence beyond what you can think and argue or logically discuss, I think these are all areas for which probably there is a big heritage, rich heritage in the country. We also need to actually glean into that and try and understand. So let me take this opportunity to compliment ASET Thiruvananthapuram for thinking of this topic, not only of that, and bringing together all the experts and make them provide some knowledge and information to the newcomers in the area and make the country progress in this particular domain. So ASET, apart from the activity what it has done, it also needs to probably look at for future how to make the activities much more hardware-oriented, conducting specific workshops or conducting events right through the year, providing competition to the academic institutions, and bringing out the new solutions to the problems that we want to address. So let me compliment the Trivandrum Center for conducting this event and wishing all the participants a great learning experience for the couple of days, and wish you all the best. Thank you.
Thank you, sir, for that encouraging speech. Dr. V. Narayanan, Director, Liquid Propulsion Systems Center, is an expert in the area of rocket propulsion. He has played crucial role in the successful development of cryogenic upper stage and making it operational for the GSLV vehicle. Under his leadership as project director, the C-25 cryogenic stage, which played a vital role in the successful launch of GSLV Mark III vehicle in its maiden attempt, was developed. Semi-cryo technology, which is crucial for the future generation heavy lift launch vehicles, has matured under his able leadership. He is a fellow and member of various national as well as international bodies in the field of engineering, space, and rocketry, which includes corresponding member of International Aeronautic and Astronautics, as well as governing council member of INAE. May I request you, sir, to release the proceedings and offer your felicitations.
Beloved Chairman ISRO, Mr. Somnath, former Chairman ISRO and National Press President AESI, Mr. A.S. Kiran Kumar, VSSC Director, Dr. S. Unnikrishnan Nair, Director IASU and IAST, Chairman AESA Trivandrum Chapter, Dr. Samdayal Dev, Director SDSC SHAR, Mr. Rajarajan, Dr. Mohan Kumar, former Director LPSC R.V. Perumal, Dr. Adimurthy, Mr. Kunyikumaran, and my dear friends, very, very good morning to all of you. Really, it is a very, very happy occasion to have the ASET conference 2022, that too in the offline mode. I remember it was on 28th December 2019, we had a major ASET event celebrating the 50th launch of the PSLV vehicle. After that, of course, there were online program, but this is the first important and happy occasion we have assembled as part of the ASET, and we are doing this conference. Really, I feel so much happy and privileged to be part of this conference. It has now been well understood that our space community has to do so many things in the area of artificial intelligence. In fact, artificial intelligence is a computer system, it's the computer system ability to clone human cognitive functions. A computer system uses math and logic through AI to simulate the reasoning that humans use to make decisions by learning new information. AI is nowadays used for complex automated systems at manufacturing plants to various robots serving key functions in deep space environment. AI and robots today serve humanity as problem solvers, companions, and first responders.
with innovations in AI technique, smart AI assistants have become extremely popular in the industry with various products coming out like Amazon's Alexa, Apple's Siri, Google AI assistant, etc. When the AI really revolution is taking place and the benefit is so much, in ISRO also we have done little bit in this area. If you take IAST, it was a long time back, we have started the MTech course in soft computing and machine learning so that we inculcate the knowledge to the next generation in this area. We have also already developed Biomitra, the space front, and AI-enabled female-looking humanoid robot to function on board in our Gaganyaan orbital spacecraft. I am also extremely happy to note that from the headquarters of ISRO, a report titled AI Anthology of ISRO was released in 2021, dealing 15 key projects in the area of AI by by different teams of different centers. Let me compliment the organizers throwing the light on Aerobots and Hydrobots in this conference. It is very, very, very clear that robotic balloons, nothing but aerobots, will significantly change the future of in situ planetary exploration. Aerobots are aerial robots usually used in the context of unmanned space probes or aerial vehicles. They can enable exploration of planets where it shall be infeasible to provide life support with the atmosphere there. And similarly, a hydrobot is a submergible robot used for underwater exploration. Hydrobots are growing into highly valuable tools for technology studies in the area where the humans cannot venture into. For example, the deepest and coolest parts of the ocean. Hydrobots' task would be detecting and mapping submerged works, rocks, and obstructions. ISRO has also taken up the development of personal sphere. I think Mr. Mohan is here. Mohan, along with the VSSC team and LPSC team, even though we are not contributing directly on the hydrobot area, we are developing the personal sphere with 100 millimeter thickness titanium alloy. It is also clear that aerobots and hydrobots can significantly influence ISRO's future deep space mission. We need to further integrate the concept of deep landing and microgravity space robotics in on-orbit operations like satellite servicing and debris management. In LPSC 2, we have started AI activities in a small scale. AI applications include health monitoring for liquid engines, stages, and data-driven virtual test facilities, and so on. I am sure this conference will deliberate next 2 days the application of artificial intelligence and come out with strong recommendations. I am also, as governing council member of Aeronautical Society of India, I wish to thank the Aeronautical Society of India Trivandrum chapter for instituting the Sri S. Ramakrishnan Memorial Lecture from this year onwards. It is really a great honor for that great person who have done great contribution in all area of space program. I wish this conference to be a grand success. Thank you. Jai Hind.
Thank you, sir, for those encouraging words. Shri A. Rajarajan, Director, Satish Dhawan Space Center, Shah, the Spaceport of India, is an expert in the design and development of composite products. His priorities are on fruition of solid motor production and launch complex infrastructure to meet the ISRO's increased demand of launches, including launches for human space program Gaganyaan and SSLV. He has led the composites team in taking up strategic developments which are highly critical for spacecraft and launch vehicle missions, re-entry applications, and human space programs. He has played a vital role in bringing many industries and partners of ISRO for development of key technologies. May I now invite you, sir, to offer your felicitations.
Respected Chairman, Sri S. Somnath, National President of ASI, Sri A.S. Kurma sir, also the former Chairman ISRO, Director VSSC, Director LPSC, Dr. D. Samdayal Dev, Director IST and Chairman of Thiruvananthapuram Chapter, ASI, and Sri Mohan Kumar, our beloved seniors Dr. R.V. Perumal sir and Adimurthy sir, and my dear colleagues, students and ladies and gentlemen, a very good morning. As the previous speakers have already explained, the AI and ML techniques is bringing a lot of inputs and improvements in the Aerobots and Hydrobots, and they can significantly contribute to the space exploration. But it also was mentioned about the importance of the human intelligence in this domain. There is a lot of debates. How do we stitch together this intelligence of the robot, the intelligence of humans, along with the capability of the robots? And it has been continuing for some time. Here it is better to recall Stephen Hawking, who famously remarked that AI will either be the best thing or the worst thing which has happened to our human face. But coming after so many decades, today we may not require to subscribe to this kind of thinking. In our collective wisdom, exploration of space may depend both on human and robotic skills. Thanks to robots, we have been getting more information on outer space, especially about the atmosphere and all those other things by sending over to survey Mars, and there are Pathfinder and Curiosity missions, which is already giving a lot of information, and a Hydrobot, actually down to the icy face of Europa, the Jupiter's Europa, where it is very difficult for the humans to survive under extreme climatic conditions. But the actual experience of an astronaut and cosmonauts over the past several years has shown the merits of the human in space exploration and to take the decision makings. In this, human flexibility, experience, and judgments are the skill sets which are unlikely to be fully automated within the foreseeable future. But to happen, we have to overcome some basic limitation in the technological limitations basically in software. Here I would like to bring some of the examples, like the murmurations of birds, especially the starlings and the survivor birds, which we usually see. Many people would have seen in short videos of all these things happens, even in our museum in Thiruvananthapuram. What if you see in the evening of this one, the way in which they make patterns of different shapes and hues. It always has to have an intricately coordinated patterns. So scientists all over the world have analyzed this, and it's already well documented in some of this. In order to collect such data, and so that it doesn't collide, each bird doesn't collide with others, where thousands of birds are involved. Each bird, by its own memory, if it starts using, it has to, the saying is around 100 million or 1 million mathematical equations to be solved per second to avoid collision, even if they make such patterns. But it is going to be very difficult, or it's impossible to have such a thing, and you have a pattern and so much artistic, this one. So here, George F. Young actually has paid attention to this way, and he says it is because of the birds follows a fixed number of their neighbors within the flock. regardless of the density of the flock. And exactly he has concluded that the number is 7. So how did he arrive at such a number, 7, to say that the birds watch only 7 birds in its neighbors and makes the decision and those? There are some clues available in our nature and this one, which has to be well utilized in promoting our artificial intelligence. The data is so high, it is available, but how to use it intelligently, this should be decided by the humans. And that can also can be automated, can be looked at as the second layer of the improvement in the robotics and aerobots, which basically the materials and this one has to be there for the aerobots and hydrobots. But when you put this and see this kind of activity and limit it, what are the critical parameters to be looked at immediate time sense and the delta T or whatever we call, there can be a very good optimization and maneuverability possible, which can be made use to us. This brings some of the coherence and improvement in this, I will say, synergy into the processing. So in this context, such brainstorming sessions, as planned in this conference, also will go a long way in reducing this gap and make it most desirable. I wish the conference all success, and thank you.
Thank you, sir, for your insightful words. May I now request Dr. D. Samdayaladev, Director, IAST, to inaugurate the virtual exhibition. Thank you, sir. May I request Dr. D. Samdayaladev, Chairman, AESI, Thiruvananthapuram Branch, to hand over a memento to Sri S. Somnath, Chairman ISRO and Secretary DOS, as a token of our appreciation and gratitude. May I now request you, sir, to hand over a memento to Sri A.S. Kiran Kumar, National President, AESI, as a token of our affection.
Thank you, sir, for doing the honors. Now may I request Dr. Mohan Kumar L., Honorary Secretary, Aeronautical Society of India, Thiruvananthapuram Branch, to propose the vote of thanks.
A good morning to all of you. Most respected Chairman ISRO, Sri Somnath, Sri A.S. Kiran Kumar, our National President of the Aeronautical Society of India and former Chairman of ISRO, our beloved Center Director of VSSC, Dr. Unnikrishnan Nair, Dr. Narayanan, Director LPSC, Dr. Sam Dayaladev, Director IASU and Director IAST, as well as the Chairman of this Organizing Committee of ASET 2022, other members of the Organizing Committee, a distinguished senior eminent scientists who are present here, our delegates and invitees, sponsors and exhibitors who are part of this conference. We have reached the concluding moments of this inaugural function, which has actually been the culmination of the dedicated and sincere efforts of a large number of team members. As the organizing secretary of this conference, I deem it as a privilege to express my deep sense of gratitude to each one of them. The conference, as the speakers earlier pointed out, has been happening after a short break due to the pandemic. And we are happy to have the conference at least now in a hybrid mode and a large number of participation from all over the country. So right from this conceptual stage, Sri Somanath, who was then Director VSSC, had shown very keen interest in our activities and extended his wholehearted support and guidance at every stage. Today, we are extremely happy to have you, sir, to inaugurate this conference and for delivering a very thought-provoking and an interesting address. Thank you very much, sir. Sri A.S. Kiran Kumar, who is the National Chairman of our Aeronautical Society of India, has been always an ardent supporter of the activities of the Thiruvananthapuram chapter. And he had regularly agreed to be our guest of honor today, as well as to release a souvenir. I express my sincere gratitude to you, sir. Our Director of VSSC, Dr. Unnikrishnan Nair, has been extending all possible support for the conduct of this conference, be it in the form of technical guidance or in the form of logistic support. On behalf of the organizing committee, I thank you, sir, for presiding over this function, for the address, as well as all the support, help, and guidance. Thank you, sir. Dr. V. Narayanan, Director LPSC, has always been a keen supporter as well as a follower of all the activities of AESI. We had many activities which have been conducted in LPSC campus as well, and LPSC forms a major size of our active membership pool as well as our organizing team. We wish to thank Dr. Narayanan and the LPSC team for all their support in terms of sponsorship, delegates, and all other help. Thank you, sir. Dr. Sam Dayal Dev, the chairman of our organizing team, has been the guiding and motivating force for all of us. The theme of the conference is something very close to his heart, and he has been a keen motivator all throughout this conduct of our proceedings. And in spite of his very busy schedules in multiple roles like Director of IASU and IAST, he has always found time to discuss and review the progress of our activities and give mid-course corrections. We place on record our sense of gratitude to him also. And this conference is organized in Vikram Sarabhai Space Center in association with two organizations, namely IASU and IAST. And we would like to place our sense of gratitude to both these organizations, both in terms of their supporting in delegates as well as the technical activities. IAST is represented in a very large number as delegates, and all our activities have been supported well. So Dr. Ayyappan, Dr. Vivian Murthy, and all other senior members of IAST, I wish to place special thanks to all of them. Thank you, sir. And IASU, the entire IASU team had been the real pillar of strength in this conference, and the artificial intelligence, they are doing a lot of good work in this one. So my special thanks to the IASU team as well. The sincere and dedicated efforts put in by each and every member of our organizing team is remembered with gratitude. Thanks are also due to a large number of supporting and auxiliary services, starting from CMG, our CASF team, the canteen and the guest house services, the photography, and special thanks are due to the computer and networking group. As you're aware, this is a conference which is going on in hybrid mode. So there are a large number of participants who are attending from different centers of ISRO as well as in other academic institutions. And we are actually going through a new online platform. So they had put in a lot of efforts to get this thing going. A special thanks to all of them. And the collective effort of all these people have culminated in the successful start of this event. And the success of any conference lies in the interest shown by the participants and delegates. And we are indeed fortunate to have very keen interest shown by all centers of ISRO, all R&D organizations of DRDL and other organizations in India, a large number of academic institutions and industries. So we thank each one of them for their interest shown in terms of sponsorships, for sending delegates, as well as participating in the exhibition, which was inaugurated some time back by Dr. Sam Dayal Dev. So I thank all of them. And our special thanks to Sri A. Rajarajan Sir, Director, Satish Dhawan Space Center. So initially, he was very busy with the activities of SS1 static test. So when we approached earlier, he was having a lot of activities in Shar. But once those things were over, he had actually found time to travel down here and to be a part of us. So Sri Rajarajan Sir has always been a very keen supporter of all our ASA activities whenever we organized our earlier conferences. So we are indeed extremely happy and fortunate to have him here for us joining in this one and felicitating us in this conference. Thank you very much, sir. And the different delegates attending from all parts of India through our online media, I wish to thank each and every one of them for their interest which they have shown in participating in this conference. And let me wish all of you a very technically enriching as well as exciting and interesting 2 days of technical deliberations. Let this event be a memorable one for each one of you. Thank you one and all. Thank you. Jai Hind.
Thank you, sir, to you too for your relentless efforts. With that, we have come to the end of the inaugural function. I request you all to rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
We are now moving on to Sri S. Ramakrishnan Memorial Lecture, which will be delivered by Sri R.V. Perumal, former Director, LPSC. I request all dignitaries on stage to occupy their seats off the dais. May I request Srimati A.P. Beena, Vice Chairperson, Aeronautical Society of India, Thiruvananthapuram branch, to accompany the speaker to the dais and to introduce the speaker to this august gathering.
Respected Chairman ISRO, Sri S. Somnath, Sri A. S. Kiran Kumar, National President ASI, Director VSSC Dr. S. Unnikrishnan Nair, Director LPSC Dr. V. Narayanan, Sri A. Rajarajan, Director SDSC, Dr. Sam Dayala Dev, Chairman ASI Thiruvananthapuram Branch and Chairman Organizing Committee of ASET 2022, R.V. Perumal Sir, Council members, former ASI presidents who have attending the conference here, and delegates. A warm good morning to all and welcome to this two-day National Conference on Artificial Intelligence Enabled Aerobots and Hydrobots, ASET 2022. We have witnessed the grand inaugural ceremony of the much-awaited conference in the ASET series after a gap of 2 years. This year, the event is all the more significant and special. As a befitting tribute to our beloved former Director VSSC Dr. S. Ramakrishnan, who left us in December 2020, ASI Thiruvananthapuram branch is introducing the Ramakrishnan Memorial Lecture as part of the ASET conference from this year onwards to be delivered by luminaries in the field of aerospace. Mentor and guru to many of us, Ramakrishnan sir's untimely demise was indeed a great loss to the launch vehicle community and our organization. A noble personality with a perfect blend of intellect, humility, and knowledge, Sir was a person who imbibed and practiced the real ISRO culture. As we all know, Ramakrishnan sir had been a keen supporter of ASI activities. Not only a supporter, he always made it a point to be part of all the events, be it the Rose program, the interaction with students, conference, and even AGM. So as a humble homage to his noble soul, we are paying our respect by organizing the memorial lecture in his name. We are indeed fortunate to have Sri R.B. Perumal, former Director LPSC and a very close associate of Sri S. Ramakrishnan, to deliver the first memorial lecture here today. In fact, both Ramakrishnan sir and Perumal sir have many attributes in common. Both are much sought after committee chairmen, known for their style of conducting reviews, very sharp and focused. They could capture the essence of discussions and bring out clarity, and also both are known for coming out with simple and practical solutions to complex problems and issues. Let me now formally introduce Sri R.B. Perumal to this audience. Sri R.B. Perumal joined ISRO in 1970 after a short stint at HAL. He has served over a decade in the Structural Engineering Division, contributing in structural design. Later moved on to PSLV project. As Deputy Project Director, Structural and Mechanical Systems, he has put in commendable efforts in the structural design area with special attention to functional requirements, realization, testing, and qualification. He was instrumental in the development of technologies and establishment of facilities, including the realization of 2.8-meter diameter marine steel motor case, setting up of manufacturing facility for large diameter light alloy structures, setting up of environmental test facilities, including first space simulation chamber, and also the integrated structural testing facilities. He has coordinated the efforts towards integration, realization, and launch of the first 3 PSLV missions as Vehicle Director and Mission Director. Later, as Project Director of the GSLV project, he led the team in the realization of the vehicle during the crucial phases of developmental and qualification testing. He has also served as Director Projects and Associate Director Vikram Sarabhai Space Center during September 2003 to October 2004. Later, as Director of LPSC, he had been instrumental in the development of liquid rocket stages and engines like the indigenous cryogenic stage for GSLV and new initiatives like the semi-cryo engines for future heavy lift launch vehicles of ISRO. He had been spearheading ISRO's efforts in industry's participation in the mechanical area and has formulated the ISRO industry participation policy, which was approved by the Space Commission. Post-superannuation, he had been with the Anna University as Vikram Sarabhai Distinguished Professor of ISRO at AU FRG Institute of CAD/CAM. A structural design guru to all of us, presently Perumal sir is offering his services as a consultant to space startup Agnikul, grooming the next generation aerospace engineers. Sri Perumal sir is also a recipient of many prestigious awards, which includes the Astronautical Society of India Award for Rocket and Related Technologies, and also the most coveted Padma Bhushan for his contributions in the area of science and technology in 2002. It's my pleasure to invite Sri R.B. Perumal sir to deliver the first Ramakrishnan Memorial Lecture as part of the ASET conference.
The laser is there, which is separately, now it is this. Okay, thank you.
Good morning to one and all. It's a great honor for me to deliver this the inaugural Ramakrishnan Memorial Lecture. Ramakrishnan has been an esteemed colleague to me, and in a way, Bina highlighted, I always felt that we had the same wavelength. A brilliant propulsion engineer who started his career in the development of RCS systems for the SLV, in the SLV program. And I am sure we had a close interaction, though I don't recollect any specific event. As I was chairman of the Failure Analysis Board during the SLV period, and RCS system used to have a number of failures. And in fact, most of my learning in various fields like metallurgy came out of this need for me to understand and resolve the failures that used to happen in the RCS systems. Of course, we achieved a very successful RCS set of systems, both for the second stage and the third stage. And Mr. Ramakrishna's contribution has been very significant in this. He joined along with me in PSLV in 1980 as project manager, initially as project manager for the liquid propulsion systems. And later, when another colleague left, who was in charge of the mechanical integration, he took up the mechanical integration also. And he built up a very, very competent team. And one of his team members today is chairman of ISRO. And probably I think I will take this opportunity on behalf of Aeronautical Society of India to congratulate him on this assuming chairmanship. Ramakrishnan was quite rational in his approach to any problem, result-oriented, and what I will call a gentleman engineer and a manager. He built up the competent team through what we can call an enabling manager. He never got into small details. He always encouraged his team members to resolve the issues, and in case they have still problems, to come to him. Otherwise, they are on their own. This is the best way in which one can bring up the team, and he had been highly successful in it. Of course, later, he took over from me as PD PSLV and saw through a set of successful launches. And over a period of time, he also assumed additional charges, like the program to develop launch vehicle health monitoring system. He was also the first chairman or the leader of the human spaceflight program. And he insisted every step of the way on the importance of documentation. So when the PSLV moved from the development phase to operational phase, he insisted on developing the operational documentation from end to end, and which will enable anybody to integrate the systems. He also laid a great emphasis through the documentation on quality assurance and ensuring the reliability of PSLV. We all know that the PSLV is a very reliable vehicle today, and to a large part, it owes to Mr. Ramakrishnan, who insisted and developed all the documentation. So it's a great pleasure it's an honor for me to deliver this lecture, and I thank the Aeronautical Society of India for giving me this opportunity. Of course, the topic they gave me is something very, very new to me. I've been keeping track of the general developments in kind of technology in terms of structures, materials, composites, and all. But I never got into the area of artificial intelligence and related topics. As we age, we are expected to learn new things so that our brain regenerates and keep itself young. So I thank Aeronautical Society of India to trying to make my brain younger. Thanks a lot. So the topic artificial intelligence has assumed very great importance as humankind is developing in its efforts. So one of the modes in which, one can understand what is the current topic of interest is looking at the Google Trends. This kind of gives a glimpse of the interest the general community has in any particular subject or item. So this gives a plot of between 2013 and close to 2017. What are the Google Trends in the related topics of artificial intelligence? Of course, the major one is the data. The data is what they call the new oil, which is going to keep the economy moving in the coming days. So we see that a lot of activity going on with reference to the data. And of course, the data is not an end itself. It is the raw material. It is a source from which the other topics like artificial intelligence and sub-units of disciplines of artificial intelligence like machine learning and deep learning are involved. Of course, you not only collect data, you have to analyze the data, and that is covered by the data science. Yep. So we see that there is a lot of activity going on in this field, and there is a lot of interest in it. My talk itself kind of tends to be a small introduction to artificial intelligence and related topics, followed by what is happening in the space technology arena. Of course, there are two overlapping things, AI and data science. These are data science is the base, and then using data science is the other related topics like artificial intelligence. Subset of that is machine learning, and a further subset of machine learning is the deep learning. Of course, there are various specialization in all these things, like general AI and super AI and things like that. Similarly, in deep learning, you have all kinds of things like supervised learning and whatnot. So if we go into kind of definitions, AI is a technology to create systems that can simulate human intelligence. And of course, ML, machine learning, is a subfield of AI which enables machines to learn from past data. There is no specific program involved in it. You start with simple algorithms and feed a lot of data and allow ML to kind of further evolve the algorithms itself and then become more and more competent. And deep learning, on the other hand, is part of ML, but then it is a targeted learning, such as voice recognition, and most important today, the hot topic of autonomous driving, etc. Of course, as I said, the data science is the very basis for all these three technologies. And it is defined as a practice of organizing and analyzing data to gain insights useful for decision making, either by humans or machines. Data analytics, data mining, etc. are these sub-branches. So very interesting view graph I came across in the internet on the AI timeline, evolution in science and popular culture. Very interestingly, it is in 1927, the first robot came in the cinema field. The robot itself is named as Maria, and it is in a movie called Metropolis. I wonder, probably it must have been silent movie period. Even in that, I think there was some director or a story writer who imagined a robot and then built it in. Subsequently, of course, there have been quite a lot of developments, and slowly, as the technology in terms of computing machines developed in parallel, we had developments in the field of what we can really call towards AI. Of course, one important step was, of course, the 1952 paper by, 1950 paper by Alan Turing, calling for whether we can ever, whether the computing machines can ever become intelligent. As an answer to the question, he also raised another question: how will we know the machines are intelligent? That's where the famous Turing test has been brought in which a monitor is asked to decide what is what between a human and a computing machine. If he couldn't distinguish which is human and which is the machine, then it is said the machine is successful, right? So there have been also, subsequent to that, Alan Turing test has been introduced, and then it has become a byword, and there is also an annual award for the best experiments in this. Okay, then slowly things were starting up, and then we had the 1956-55 a conference in the UK, which first time coined the word artificial intelligence. And in 1950, the whole period, the 1950s, it is said that artificial intelligence was generally being used in toys. Okay, so we outgrew, and what we see really industrial robo was introduced in General Motors production line in 1961. If you have seen this, any picture of the automotive production lines, particularly the shell part of it, you will see plenty of robots, row after row after row of robots doing the assembly operations through spot welding. That originated in 1961. Another major milestone in cinematography, or even the idea of space robots. In fact, the first time the concept of space robot came into picture is in the picture 2001, A Space Odyssey. I'm sure you must see this movie. Probably today it's available in various sites. Basically, it's about an interplanetary mission wherein the spacecraft is traveling with a set of astronauts, I think about 5 of them. 4 of them are put in hibernation to save energy and to save their physical conditions also, as they are to be young. There was one person who was allowed as a supervisor, but then the space mission itself is being totally managed by a computer called HAL. At some point of time in the mission, the HAL becomes a rogue, and decides why the hell it should obey the humans. It will take over the entire mission. So in the process, it kind of kills the 4 astronauts who are in the hibernation. And then it is realized by the one man who is supervising, and then who enables the computer. And then you must hear the computer pleading with him not to deactivate it. It's a very interesting movie. But then it also, in a way, what people are worried about, highlights why people are worried about artificial intelligence. Yeah? Okay, so subsequently, I think towards the end of 60s, a question arose, what is the relevance of AI? And it is not giving enough kind of output for the kind of research funding that is being done. So there was a report based on which what is called the first AI winter was gone into, in which the entire funding was cut. All the research and development were more or less stopped. So it was almost for a period of a decade, and early the entire period of 80s, we can say that there was no funding for AI itself. But then towards the end again, 87 or so, another report came out by which we must further go ahead. And that's where the funding into machine learning was introduced, and in a big way, the machine learning area was developed. Okay? So we had the result of which, of course, independent companies did it. 1997, the IBM's Deep Blue had a chess match with Garry Kasparov, then the world champion, and he was beaten in it, and then the Deep Blue won the chess match. So again, introducing a kind of interest in AI itself. Of course, in the 2000s, and a number of movies came in, as already have been mentioned, like Star Trek and whatnot. And then we had, of course, the deep learning also was introduced. And then we had like the voice processors like Siri and Alexa and whatnot. So today we are into more areas, and certainly in starting with the 2000, and we also had a lot of interest in employing AI into space technology. But then, as has been highlighted, the AI system has to be taught by humans. It's not that it has got an innate intelligence. Like a bee, when it comes out of its hive, it knows how to fly and then how to navigate. That's not possible for any machine. Otherwise, you train it. And the training process involves complex computer codes and a lot of training data sets. And then it's not that you can feed the raw data. The raw data has to be unedited. A human has to sit, and what is the input and what is the output and how they are related has to be unedited and then given as an input to the AI systems. So there is enormous amount of human effort is involved in training the AI systems. There is, of course, a shortcut in terms of the machine learning, wherein, as I said, you start with a simple algorithm and feed the data. Of course, it is, again, annotated data, so that the machine itself starts improving the algorithms and becomes more and more intelligent. So this is the kind of overview of what AI system and how it kind of operates. So coming to space applications itself, we have kind of 5 areas which I note in which AI is being introduced. Of course, that is, the major is, of course, satellite data processing. And the other things are space debris monitoring, navigation systems in planets, astronaut assistance, and lastly, mission design and planning. We'll get into details of each one of them. You know, satellite data processing is a very fertile area for the application of AI because they generate enormous amount of data, something like 150 terabytes every day. How does one analyze? If you want to put humans, probably the entire humanity has to get into the process of analyzing this data. This is where the deep learning and AI provide significant power to analyze this data. Of course, if you have enough computing power in the spacecraft itself, and then implement AI in it, AI can decide on the quality of images practically in real time when the sensing is going on, and take corrective actions where required. Like, for example, asking the another satellite or decide on the revisit and things like that. So what is the advantage of it is, you don't have to download this 150 terabytes to the Earth and start analyzing. So there is a great advantage in trying to, in enabling the satellites to do the data analysis on board. Of course, there are some satellites, all these things have been tried. Earth Observing Satellite 1 is an AI-enabled satellite, and it has been in service over the past decade. And then it has been so smart it has become that it can detect calamities even before the ground crew became aware of it. And it is recorded that EVO-1 was the first to detect active lava flow, methane leakage, and regrowth of Amazon forests. ISRO also monitors forest cover now using smaller areas like up to the extent of down to 1 hectare by using AI and automation techniques for analyzing optical remote sensing data. So we are already doing it in ISRO. Another area is the flight operations. Particularly when it comes to the science observations using Hubble, Chandra, and all that, there is plenty of conflicting demands from various scientists. And then maneuvering a satellite in orbit is very costly in terms of the fuel being consumed, and therefore it must be optimized. So AI-based automated planning has found a natural role in these complex operations. The spike system used to schedule the Hubble telescope is said to have increased the observations by almost 30%. And the spike derivatives have been used for other observatories like Chandra, as also the ground-based radio observatories. NASA's Deep Space Network, which is the backbone for getting this data, is also done, scheduling is done using AI. And then this, through AI systems, they've been able to meet the demand for hundreds of tracks every week. Okay, one of the major worries in any spacecraft mission today is space debris avoidance. Tracking and characterizing the orbits of ever-increasing number of space debris is a huge and continuous job. Again, we have to crunch enormous amount of data. The deep learning is used to enhance the laser ranging technology with the back propagation neural network models for pinpointing the orbital details of various debris. ISRO's own attempt to develop its library of debris using the multi-object tracking radar is availing ML and AI techniques. There is another SpaceX Starlink is set to use the AI-based system for avoiding the collision. However, can one system alone using AI will be feasible in avoiding collision? Question is like this, the flying of Starlinks in hundreds and thousands of numbers. How do they avoid collision? Is it each bird has to be aware of the other birds? And I presume there must be certain traffic rules inbuilt. Like in road, we must overtake on the right. Is there a system in this Starlink satellites that it will enable collision by the very act of maneuvers for collision avoidance? That's an issue that is yet to be resolved. We don't know if two independently artificially enabled satellites trying to maneuver each will end up colliding with each other. That's a thing that remains a worry today. And of course, it has been highlighted that we need to navigate in outer planets, of which we know very little. So how do we do it? This is a picture of one of the Mars exploration rovers. Oh, sorry. Yeah, ground navigation in outer planets. A NASA Intel AI system has been designed to assist navigation in Moon and Mars. How do we do it? First, we need to have a total topography captured by terrain cameras of the onboard orbiting satellites, which are converted into data and then fed to these rovers. And then rovers, using the images and neural network, create a virtual map, and then they use it for navigating on the planets. This has been a very great help and used extensively. I think the astronaut assistant has been highlighted, including what ISRO itself is developing. And the whole idea is it will enable more efficient functioning of the astronauts. And the companion in space like Siri and Alexa, with whom the astronauts can talk. There are already 2 experiments have been going on. One is crew interactive mobile companion called Simon, and in ISS, International Space Station, developed by ESA and DLR, and it has been operational since 2019. There was also an earlier version which was working in 2018. The whole idea of, and also there is an intelligent ball, a Japanese assistant, which is already functional in Japanese module of ISS. Of course, one is aiming to have a more companionable companion in terms of one which can understand the emotions and behave in accord with those emotions of the astronauts. This is a picture of the Simon, which is can navigate independently and then go and be there wherever it is asked to be commanded. The propulsion is achieved through 12 numbers of fans which are incorporated in this module, and it navigates using the LiDAR within the confines itself. Okay, and then this is the intelligent ball or INT ball of Japan. Basically, it's a companion which is supposed to photographically record and also videograph of all the activities and experiments that is going on in the module. Okay, and one of the dreams have been how to extend the life of the spacecraft in orbit, for which obviously you need on-orbit maintenance and servicing. Servicing means you may have to even load propellants, etc. And then NASA's on-orbit servicing, assembly and manufacturing one is the pioneering satellites designed to service the other spacecraft. And this calls for a lot of AI and ML technologies, because the spacecraft has to do navigation in real time, and then it has to have a dexterous robotic arms and advanced tools to execute the servicing tasks, like capturing the satellites and then trying to make the umbilicals wherever it is required, and then service the satellite. So this has been going on very successfully for quite some time now. There is also, of course, the health monitoring of satellites is another important aspect. And research in AI for spacecraft resilience is RACER, uses a combination of ML and AI for health monitoring. ML actually diagnoses based on the past occurrence, which is what ML is specifically designed and good at. And the AI analyzes situations that have not happened earlier to inform the decisions. Of course, here the ground crew has to come in and then authorize whatever the actions are required. One of the most important area in which AI has been very successful is in space science. When we are looking at the space and imagining it, we really don't know what we are looking at, we know what we want to look at or what we want to design, but then what we capture is not really what it is, and then how to analyze the data to arrive at what we are looking for is there or not. So this is where AI ML comes in a big way. So the first image of the black hole itself has been arrived at using continuous high-resolution image reconstruction with a Bayesian algorithm and Python libraries to scale down the data and ML to arrive at the image. Similarly, the Kepler spacecraft, observatory, which is looking at discovering new planets, have been using AI-related technologies, and then by constructing the convolutional neural networks named Astronet K2, 2 exoplanets, sorry for the spelling mistake, exoplanets have been successfully identified. So these are the things in which it is have been gone with reference to what I can even say that in-orbit assistance or AI technologies which are helping in-orbit spacecraft. Now, coming down to manufacturing area itself, what is really happening is, of course, the 3D printing is coming in a big way. And the relativity space uses Stargate printer to build 10-meter tall tankage end to end, just from aft end flange to the forward end flange, including the skirt extensions are being built with aluminum alloy and the plasma arc process. Where AI comes in is a suite of sensors to capture the process as it happening and train the printer using for defect-free hardware. They have been very successful. Of course, today in India itself, the startups are using liquid engine, using 3D printing for printing liquid engine hardware. And I was amazed to say, look at that entire chamber, including the injector, has been 3D printed, requiring only the connections at the input level for both the oxidizer and the fuel. And I'm sure, of course, right now AI is not being used. I'm sure they need to bring in AI, just like in Stargate printer, so that the defects can be monitored. There is a lot of work going on in analyzing the stability of liquid rocket engines. University of Texas is supposed to be developing a ML framework, blending physics and data, enabling simulation with the perturbations on the stability of rocket engines. And control of rocket engines, a team under InSight Fellow program is developing control laws using reinforced learning. ISRO, of course, is developing a vehicle data system knowledge in IASU as a semantic knowledge base and an intelligent processor to extract data for mission simulation. So these are the areas in which you can say the AI effort is going on in a big way. Okay, with reference to what is happening in a kind of symposium and meetings and other things, I try to highlight three areas, things that's going on. International Symposium on AI, Robotics and Automation, ICIRAS, since 1990. It is a biannual meet on those relevant areas. There is also International Workshop on Planning and Scheduling for Space since 1997. This is also a biannual meet. Very interestingly, there is a NASA organizes what is called a Frontier Development Lab, FDL, every year in the summer for 8 weeks, wherein it brings all interested people, put them together for a collaborative work for 8 weeks to brainstorm and develop codes for AI. And instantly, these codes are available as an open source. So one can access it and then see where we can also avail those codes in our own effort. Okay. Are we free of issues? Obviously, any development in any new field have issues. So, as have been highlighted, the AI depends upon a database. Now, where do you get database for space-related systems? Because it is not like you're ordering some item in Amazon and it gets logged in data and then it is analyzed by an AI. So next time you log into Amazon, it immediately pops up, this is what you are looking for kind of thing. It's not possible in, that kind of data is not possible in spacecraft. So we need to build the database, and that is a long-term as we proceed. The other thing is any software we use in space, we try to analyze. In fact, there is a walkthrough of the codes. Okay, so whereas in machine learning, when it tries to do that, it's totally a black box. You don't know what it is, and it's not accessible to you to analyze. Okay, so the question is, what is the reliability you are looking for? Are you happy where you are operating with a black box on the reliability of the system? So this is something that is not really resolved. Of course, even in common areas, though AI is coming in a big way, there are questions. I think the gentleman who initiated or introduced deep learning declared in 2016 that there is no more need for radiologists because the AI system can analyze the CT and the MRI scans so well that no more radiologists need to be trained or employed. Now we are, as it is said, we are 5 years down the line. No radiologist has been either dismissed or the field has not suffered any damage in terms of their requirements. I don't know. I think before AI became in the past 2 decades, we've been talking about the previous 2 decades about nanotechnology, right? Okay, it is going to come so much, this and that and whatnot. But then what really has happened? Today, nobody even remembers nanotechnology, I think. The question is whether it is really going to live up to the promise it is giving, right? So, you know, we say the neurons in brain. The neurons in brain are fed by dendrils. Each neuron is connected to something like 1,000 dendrils. That means it is feeding data to a single neuron. And then it gives an output, what is called axon, which is like either 0 or 1, depending upon the excitation state or the conclusion that neuron itself has derived at. And then it feeds into the other neurons. Basically, there are 100 billion neurons in the brain, and it is said there are 50 terabytes of data it can really store. Yeah? No computer system can match it. I don't think there can be a parallel processor with more than 100 processors. Even that will be a big affair in terms of sharing data. And also when the number increases, the whole thing slows down, right? Whereas the neurons can handle 1,000 dendrils, 1,000 inputs, okay? So it's a big challenge. Probably physical impossibility, I will say, that we will beat the brain, yeah? So how do we do it? And a brain like Einstein, I don't think it is programmed. I mean, how did it find out the relativity theory? This is something very intuitive, and then AI cannot be very intuitive either. So these are things that one has to really remember when we hype about AI. And of course, when you come to space itself, because of the database, it gets even more shrunk. Okay. These are the few words on which I wanted to convey. Thank you very much. And as I said, thanks a lot for Aero Society for giving me this opportunity. Thank you once again.
Thank you, sir, for that very interesting and informative talk and for taking us down the memory lane by sharing memories of our beloved Ramakrishnan, sir. May I now request Director VSSC to present a memento to Shri R.V. Perumal as a token of our gratitude.
Ladies and gentlemen, we will continue with the keynote lectures and technical sessions after the lunch break. The first lecture will be delivered by Professor V. Kamakodi, Director, IIT Madras. Now I request you all to join us for a sumptuous lunch at Scientist Hostel VRC area. Delegates can find their lunch coupons and dinner coupons inside their conference kits. Shuttle buses are waiting outside. Please join us back for the keynote lecture precisely at 2 p.m.
Thank you all for being a wonderful audience. Have a very pleasant day ahead.